Hey guys, so in this tutorial we're gonna discuss how to delete middle node of single linked list. So let's get started. So while deleting the middle node of single linked list, we have to take care of two use cases. The first use case will be when there are nodes available and the length of single linked list nodes will be even. As you can see in this list, we have 4 nodes with data value 10, 20, 30 and 40. So if we find the middle of this list, so we will be getting two middle nodes. One will be 20 and another one will be 30. So now the question is, which one should we delete? So we will be giving preference to the second middle node and we'll be deleting the second middle node of this list. And after deletion of node, the remaining nodes will be 10, 20 and 40. So this second middle node will no longer available. This is the first use case. The second use case will be when there are nodes available and the length of singly linked list nodes will be odd. As you can see, we have 5 nodes with data value 10, 20, 30, 40 and 50. So the middle of this list we will have a node which has data 30. Now we have to delete this node. So after deletion of this node, the remaining nodes will be 10, 20, 40 and 50. So now we have to take care of these two use cases while writing the backend logic. Now this is the graphical representation discussion. Now let's get started with backend code. So for that I have already created one class with name delete node. Inside that we'll be developing one method which will be taking care of deleting the middle node of single linked list with these two use cases. So let's get started with backend program. Private return type will be void and method name will be from middle. So this method will not have any input parameter. So the first step will be we'll be creating a head of node type, node of head. Now we will be checking whether this head is null or not. If it is non-null, then we will be using pointer approach. So we'll be using 3 pointers which will be basically pointing to the first node of single linked list. So let's create pointer here. So let's create one dummy list with data value 10, 20, 30 and 40. 40 next will be pointing to null. So we will be using 3 pointer. The first pointer will be previous pointer, second pointer will be slow pointer and third pointer will be fast pointer. So initially these pointer will be pointing wherever our head is pointing. So let's create this pointer node, and first will be previous, second will be slow pointer and third will be fast pointer. Let's initialize this pointer. Slow is equal to fast. So these all will be pointing to head initially. Now we have to check whether the fast is null or not. Non-null, fast. And another condition will be if fast reference is null or not, because we will be moving fast pointer 2 steps forward at a time. So the remaining pointer will be moving one step forward at a time, but this is the fast pointer, so this will be moving 2 steps forward at a time. Okay, now if this condition is true, means fast is pointing to fast is not null and fast next is not null. So fast is pointing to wherever head is pointing. So head is initially pointing to first node of singly linked list, right? Now we will be checking whether fast is null or not, and the fast reference is null or not. So fast is not null. The fast reference is this, right? It's also not null. So let's move. So in first step we will be moving, we'll be assigning slow to previous. Wherever slow was pointing, previous will start pointing to that node. So slow is pointing to 10, so previous will start pointing to this 10 node. Okay, now the second is we'll be moving slow pointer one step forward. Okay, now when we execute this line of code, so slow will be start moving one step forward, this. Now the another one is fast will be moving 2 step forward. So we have moved one step, let's move this one step. Now it should move 2 step at a time. So get next. Now let's move this 2 step. All right, now this is done. This is the first iteration. In the second iteration it will check whether this fast is pointing to null or not, and another one is fast reference is pointing to null or not, right? So fast is pointing to 30, it's not null, this condition is true, right? Fast is non null, this is true, and the fast reference is pointing to this, which has data value as 40. This condition is also true because fast reference is not null, this is true. It will come inside this while loop again, and we will execute this first line. So now this first line is what it is doing. So wherever slow is pointing, previous will start pointing to that node. Right now slow is pointing to node which has data value 20, and previous will start pointing to the same node where slow pointer is pointing, right? This is done. Now we will be executing second line of this while loop expression. So this what this line is doing, slow is equal to slow dot get next, means we will be moving slow pointer one step forward. So when we execute this line, it will move slow pointer one step forward. Okay, now we have done executing this line. Now it comes to third line, third statement of while loop. Now with executing this line of code, our fast pointer will move 2 step forward. So 1 step, and this is 2 step. Now as you can see, this fast pointer is pointing to null, so the value of this fast pointer is null. Now we will be checking whether fast pointer is non-null, but it's null, so it will, this condition will false, it will come outside this come outside to this while loop. Now at that point, when we will be exit from this loop, at that point our slow pointer will be pointing to the second center node of second middle node of singly linked list, and previous will be pointing to first middle node of singly linked list, as you can see here, right? So these are the two middle node of singly linked list in case of even length of singly linked list. Now what we have to do here is we have to assign this node to wherever slow dot next is pointing, right? So slow is this, and slow next is pointing to this node, right? So wherever slow dot next is pointing, our previous pointer should start pointing to that node. So means previous should start pointing wherever slow dot next is pointing, that is this, right? Directly here to here. So this reference will be removed, and this will applicable for garbage collection, right? So let's do this. What we have discussed, the previous dot set next will be previous next should start pointing slow dot get next. Slow is this, and get next means the reference of slow is this. So slow dot get next, right? Now with this line of code, this previous pointer will start pointing to this node. Okay, and the reference of this middle node, second middle node, will no longer available, so this will be applicable for garbage collection. Now if this is the first use case, right? And what happen if head is null? At that point we will be printing message saying linked list is empty, linked list is empty. That's fine. This is the first use case. Now the second use case, when we have odd linked list length. So let's add one another. Now you can see we have odd length 10, 20, 30, 40 and 50. 1, 2, 3, 4, 5. Now the center of this node is 30. Let's execute this again. Initially our all pointer will be pointing wherever head is pointing. So initially head will be pointing to this node, right? First node of singly linked list. Now so we have declared these all and assigned the value to these pointers. Now let's execute this, right? So fast is not null, and fast reference is also not null, right? Because it's pointing to first node and reference is pointing to second node. So we'll be coming inside this while loop, and we'll be executing first statement of this while loop. Slow will be pointing to, previous will be pointing wherever slow is pointing to. So slow is right now pointing is first node of singly linked list. So previous will start pointing to the same, and we will be moving execution to the second statement of while loop. Now as per this, slow is equal to slow dot get next, means we will be moving slow one step forward. Okay, now it comes to this. So here we will be moving fast pointer 2 step forward. Let's move. This is the first step, this is the second step, right? Now we'll be checking whether fast is null or not. So fast is pointing to data node 30, and again another condition is fast reference fast dot get next, means fast reference is null or not. So fast is this and fast reference is this, pointing to this node. So it's not null. Again it will come inside this while loop and it will execute first statement of this while loop. So as per this, previous will start pointing wherever slow is pointing. So previous will start pointing wherever slow pointer is pointing, that is node 20. Now the second statement of this while loop is will be moving slow pointer by 1 step forward. Done, right? And another one will be fast pointer will be moving 2 step forward. So this is a 1 step and this is a 2 step, right? And now in third iteration we'll be checking. So this fast value is updated, slow value is updated, and previous value is also updated, right? And with this fast updated value we will be checking these conditions whether it's pointing to null or not. So fast is pointing to last node, right? But fast next is pointing to null. But what we are expecting, fast dot get next should not point to null, non-null, right? It should not point to null. So this condition is true, right? But this condition is false. So as we are using this AND operator, for AND operator both conditions should be true, then only the entire condition will be true, otherwise it will not come inside this. So as this first condition is true and second is false, means entire condition will be false, it will come outside this loop. Now as I said, when we exit from this while loop, at that point our slow pointer will be pointing to middle node, right? So you can see here slow pointer is pointing to this node and previous pointer is pointing the previous node of middle node. So now this previous pointer reference should start pointing to wherever slow dot next, means slow reference is pointing. So slow is this, right? and the slow reference is next node. So wherever slow reference is pointing, so previous pointer reference should start pointing to this node, right? So this is what we have done here. Slow dot set next is equal to slow dot get next. Sorry, previous dot set next means previous next we are initializing with slow dot get next, means from here to here. So this code is taking care of these two use cases. Now we will be done with these two use cases. Now let's write main method, and we will be verifying whether our both use cases is handled properly or not. Now let's create a multiple nodes first. Let me give proper comment here. Creating multiple nodes. Multiple nodes, right? So let's create node first is equal to new node as 10. Let's copy and paste this. So we will be checking the first use case when there are only 4 nodes available, means the length of simply linked list nodes will be even. So this will be second, third, fourth. The value will be 20, 30 and 40, right? Now let's connect these nodes together. Connecting nodes together to frame chain of linked list, right? Now let's connect them together. So what we will be doing, we have to create a object of this current class. So delete node list is equal to new delete node, right? Using this reference we will be accessing these methods, right? These are the non-static field, right? And this is a non-static method, so we will not be able to access these non-static members inside the static block, right? So using this list we'll be able to access these non-static members. So list dot head is equal to first, right? Now first dot set next is equal to second. So second dot set next will be third. Likewise third dot set next will be fourth. So there are no any nodes available, so fourth will be pointing to the null. Now next to this we have to call print simply linked list method, which will be taking care of printing all the elements of simply linked list. So printing all the elements of singly linked list. So we have already created one class with name print linked list dot, which has display method and which is expecting input as head of node type. Now let's run this and verify whether we are getting a list of nodes, right? We are getting the list of nodes with data value 10, 20, 30 and 40. Now let's call delete method, right? So performing DELE delete a node from middle operation. Okay, let's go here. Let's call list dot, this reference should be delete node, right? Delete node from middle. Okay, now after this we'll be printing the these nodes, right, to verify whether our operation is successful or not. Delete operation is successful or not. Let's run this. Now you can see this is the first initial list which we have created, right after this chain we have printed this. Now after that we have performed delete operation. Now we are printing it again. So for even we have two middle nodes, and we are deleting the second middle node, right? And you can see this node which has data 30 is not longer available in after this operation, right? So 20 node is directly pointing to 40. 20 is pointing to 40. So this is the even linked list node length. Now let's add one more so that we will be having we will be able to test another use case where we will be having linked list node length will be odd, fifth, which is data value 50. Now this also we have to add here. Fourth dot set next will be fifth, right? Now let's print that, and the output of this will be, I can explain you that, right? And the output of this will be so this is the middle node, this will be deleted. Now output should be like this. Okay, now this is the input which has this is the input without any delete operation, and after delete operation we will be having output like this. Okay, let's run this again. Yeah, you can see here. So this is the output. You can see they are the same, right? So the middle node is 30, right? And after performing the delete operation from middle, the 30 node is deleted, and you can see the 20 node is directly pointing to 40. 20 is directly pointing to node which has data value 40. Now this use case is also handled. So both use cases are working fine, and we have done with this video, guys, and thank you so much for watching this video. Thank you.